Okay, you've already seen this function called type right earlier. Okay, for example, you can do type in is equal to in, so it's integer. Now let's look at another function that is called instance and is similar, right? So suppose you have a vehicle class and you have a truck class that is a subclass of the vehicle class. So a truck is a vehicle. Now, if you do isinstance vehicle, then you return true because the vehicle is obviously an instance of vehicle, right? If you do type of vehicle, you get vehicle. Right? If you do isinstance truck vehicle, answer is true because a truck is a type of vehicle. A type of truck is a vehicle is false, right? Because a type of truck is actually truck, not vehicle. Now, if the type of truck equals truck is true, yes. Okay, now let's look at another example where we have a speaker. So let's take a look. What does this speaker do? Well, it's a very simple object, right? The speaker here inherits from object, the basic POP object class. And then what it does is it's got one method called say, and then it's stuff, and then when you call say stuff, it prints the stuff. Very simple. Now, suppose if Abing a speaker and Abing says hello world, you get hello world. Okay, and you ask Abing to dance, then bad things happen. You've seen something about inheritance in the space war simulation. Now let's take a look at this topic in a slightly more detail. So let's take a look. Suppose an object inherits an object, then we may say that the inherited object is a more specialized version of the superclass. Right, for example, a lecturer is kind of speaker. Okay, a lecturer also has a method called lecture. Okay, so we are defining a new object called lecturer. There's a kind of speaker, so it inherits from speaker, and an extra method called lecture. Right, and the thing about lecture is that to lecturer will say something, and then you should be taking notes. Right, so this is how we will try to implement lecturer. Okay, so a lecturer can do anything a speaker can. This means that the lecturer inherits the same method from a speaker because speaker can speak, and the lecturer is a subclass of speaker. Okay, the speaker is therefore a superclass of lecturer. So this is how you do it. So a lecturer, okay, inherits from speaker, right? And then you can lecture. And when we do that, you call self.say, right? But say is not here, so Python will go up the class, okay, which means you go up to the speaker class and look for say, and it finds it, and then you will say stuff. And then after that, you will say you should be taking notes. Okay, so let's say Steph, that's my colleague. He's a lecturer, okay, and if you do lecture, Java is easy, you go Java is easy, you should be taking notes, right? If Steph says you have a quiz today, you just say you have a quiz today. So basically, if you lecture, you will say the stuff, and then you should add this extra line. If you just do say, you will call the method in the superclass, and all you do is just to print out the message. So let's take a look at another example called ArrogantLecturer. So basically, we define ArrogantLecturer to be a kind of lecturer, which is fair enough. But whenever ArrogantLecturer says something, he or she will add something extra, which is the favorite phrase. Now let's take a look. So the ArrogantLecturer, right, is a subclass of lecturer, right, and it takes in a favorite phrase. So now it sets a favorite phrase to this favorite phrase, okay. And basically, when this ArrogantLecturer says anything, you will call the superclass to say the stuff plus the favorite phrase. Right, so super allows us to access methods in the superclass. Now, if you don't call super say, then essentially, which is what say happens, right? So when you first call say, you hit this particular method, and this particular method will call super and call the say there. Let's take a look at how this works. So Ben, for example, is arrogant lecturer, and he likes to say, "How cool is that?" Okay, so Ben, when you ask him to say something like "We have midterm tomorrow," he will say, "We have midterm tomorrow. How cool is that?" You ask him to lecture, Python is cool, and he will do what? Python is cool, how cool is that? And then he will remind you to take notes and say, how cool is that? Right. So this is polymorphism because for the same function, it actually does different things for different objects. So OOP allows us to a very convenient means of handling what you call polymorphic functions, which means that you can actually have functions that take in different types of arguments and different numbers of arguments, right? On the other hand, you also have this thing called overriding, which is that you have the same method in both the subclass as well as superclass with the same name and also the same arguments. And depending on who you will call a different function or method in a different object. So for example, if you use say, all right, for a speaker, a lecturer, and arrogant lecturer, okay, they will be accessing different methods. So the speaker will access its own speaker method, the lecturer will access the speaker say method, and then the arrogant lecturer will access its own say method, which we then call the speaker say method. Question is, how would you do overloading in Python? Okay, we have done a lot of overriding. How would you do overloading? Okay, we can discuss this in class, or you can put it on a forum. Now, The benefit of polymorphism is that the programmer doesn't need to worry about what type of object. He just takes the object, shoves it into the method, and it takes care of the thing, right? And now the programmer can just focus on the message, on what to do. It turns out that it's possible for a class to inherit from more than one parent class. So for example, in this case, your C will inherit from both A and B, right? So in other words, C is subclass of both A and B. Now, so here A has foo, B has bar, right? And then when a class inherits from two different superclasses, it will inherit both the state as well as the methods from both classes. So in this case, C has yum, so C has methods foo, bar, and yum. Now, multiple inheritance turns out has got some issues. So not all languages will support this. Python will support multiple inheritance. And the key problem is this problem in resolution order. So what does resolution order mean? For example, if A has foo, B has foo, and now C calls foo. The question now is whether C should call foo in A or C should call foo in B. Right, so this is a concern. Let's look at an example on how multiple inheritance will work. Let's look at this example called singer. Singer is this object. What does the singer do? Well, it says and it also sings, right? So when you ask the singer to say something, then you go tra-la-la something. You ask the singer to sing, you will just go tra-la-la. What is the singer a subclass of? The singer is obviously a subclass of this thing here, which is object. Now, suppose Ben decides to moonlight as a singer. So you have this thing called a singing arrogant lecturer, right? So a singing arrogant lecturer, right, is now a subclass of both arrogant lecturer as well as singer, right? And now the init will do what? Init will basically take a favorite phrase and call super init favorite phrase. Well, it turns out that because the arrogant lecturer is one that has a favorite phrase, so this thing will call the arrogant lecturer, right? Now, so this ordering matters, okay? So suppose Ben equals to singing arrogant lecturer. How cool is that? Ben.say we have re-exam tomorrow. What happens? Well, he'll say the exam's tomorrow. How cool is that? Now, suppose Ben lectures, okay? He'll say Python is cool. How cool is that? You should take notes, right? Now, suppose you ask Ben to sing. What happens? Well, he will sing because he's also a singer. Now, the complication arises when the same method is available in two classes, right? So Ben is both a singer and lecturer, but primarily a lecturer. So essentially, if the internal arrogant lecturer has a method with the same name as the message, then that method is returned first. If not, you check the singer. If not, then you will go to fail. Okay, what are the benefits of OOP? OOP will simplify complex hierarchical structure by putting it together in a very natural organization. OOP also allows you to reuse code easily because the same code is being used by all the subclasses. Basically, if you want to do something a bit differently, okay, you can create a new class. In the subclass, you override the method in the parent class, and then essentially you can do something, and then you can call the super.method, and you can call the method in the parent class as well. It's more intuitive to use OOP, and you can handle details, you handle all the details of message passing polymorphism under the hood, so you don't have to worry. But it turns out that OOP does have some cost. So basically the creation of classes, methods, instances, there's some amount of overhead, but typically they are small, so OOP languages are very popular. So Python supports it, Java, C++, or OOP. Now, so there are a few major paradigms in programming. The earlier ones are like imperative, C, Pascal, Algo, Fortran, There's also functional programming, Scheme, ML, Haskell. And there's this class called logical programming, Prolog, okay? And the more common types today are the OOP languages, Java, C++. Smalltalk is a bit older, but Smalltalk is also one of them. Now, Python, what kind of program paradigm is this? Okay, I'll leave you to think about this. We can discuss it in the forum. So you have so many paradigms. What's the best one? Well, it turns out that the answer is that it depends. So certain tasks, it turns out, will be particularly suited for certain languages, right? But what is true is that almost languages are Turing complete. So basically, you can do anything you can do in one language in another language. It's just that in some cases, it's more complicated in some languages than others, right? So the moral story is to look at the problem, understand the problem, and pick the right language for the problem. Okay, now the summary for today's class, we talk about classes, which are the high-level blueprints of the objects, right? Instances are particular objects of each class, each with their unique state, right? And typically in classes, you have this hierarchy, okay? And inheritance allows the state and behavior of superclass to be inherited by the subclass, which can extend the behavior of the superclass. Well, and then if you have multiple inheritance, then you need some rules of figuring out which methods to apply. And polymorphism basically allows you to use the same method name, right, to do different things in different places. And sometimes you can also do overloading, whereby you can have the same method name with different sorts of arguments.